Have you ever heard terms like ON, O-log-N, or O1 in computer science? You know, those words that instantly make everyone look smarter. Yes, before I understood them, every time someone said these terms, I felt like they were casting a spell. But today, we're breaking it down the easy way. Imagine you have a giant list of users, like user 001 all the way to user 999. And now you want to find user 999. You start scanning from the top, one by one, slowly. This is ON. The time it takes grows with the length of the list. If you have 1 million items, guess what? You do 1 million checks. Your soul slowly leaves your body. But then, Dictionary enters like a superhero. It's a collection of key-value pairs, each unique key mapped to a value. But the part that feels like black magic is this. Dictionary uses a hash table internally. Imagine you are the target that Dictionary want to find. You ask Dictionary, "Why do you find me so fast?" Dictionary will answer, "I just know where you are, I go straight to you." Yes, it's true. When you add something into a dictionary, C# runs a hash function, like a math spell that decides which drawer to put your item into. Then later, when you search for the same key, it runs the same math, gets the same drawer number, opens that exact drawer, and boom, item found. That's O1 time complexity. Means that whether you have 100 items or a million items, it still takes about the same time to find an item because it goes directly to it. Now, a quick trade-off. Dictionary is faster but uses more memory than a list because it needs space for its buckets. But honestly, we love the speed, so it's worth it. Now, let's see some dictionary operations. Declare a dictionary like this, with the data type for the key and value. To add item, we can use .add, but it will throw an exception if the key already exists. So, before adding, you can check if the key exists by using contains key. Or use triad like this, or set the value like this. This will add the item if the key does not exist or update the item if the key already exists. Now, to retrieve a value, we can use this method, but take note that we'll get key not found exception if the key is not there. A safer way is to use try-get-value like this. Now, to iterate a dictionary, we can loop like this and access the key and value inside the for each loop. You might be wondering, when we iterate the dictionary, will it follow the order that we add the item? Answer is no. Dictionary does not guarantee the order. Most of the time you get the same order by coincidence. But when there is removal or rehashing happens, the order messed up. When we remove an item, this creates a hole in the internal array. The next item you add might fill that hole, appearing earlier in the dictionary. If the dictionary gets too full, it automatically expands and rehashes everything to find new bucket slots, which completely reshuffles the order. So, if you need guaranteed order, you can use OrderedDictionary. It keeps insertion order and does O1 lookup by combining two data structures. In simple terms, it uses a list to remember order and uses a hash table for fast lookup. Next, let's dive into a major sign you should switch to use dictionary. Imagine this code. If there are 50,000 categories and 10,000 subcategories, you just created 50,000 times 10,000 lookups. This is a classic O and times M disaster. So, when you're about to put a first or default inside of for each loop, it's a huge sign to use dictionary. First, build a dictionary once. We pay only one-time cost. Then, all lookups inside for each become O1, drastically faster than before. Another pro tip, pre-size your dictionary. If you know you'll store around 1,000 items, pre-size the dictionary like this, because dictionary expands itself when full. This triggers rehashing, which is expensive. Pre-sizing avoids the rehashing and gives maximum performance. Now, let's see some real use cases in ASP.NET Core. First, map enum to a user-friendly message. In this case, we can retrieve the message based on the enum. Next, grouping data for reports. You get a list of order from the database, but you want to show them grouped by customer. This dictionary, which maps the customer ID to list of order, is perfect in this scenario. Now, let's talk about concurrent dictionary. Yup, 95% of the time, normal dictionary is already enough. But when multiple threads try updating the same dictionary at the same time, invalid operation exception. Classic example is the Signalar online users list. Users connect and disconnect randomly. One thread goes, I add user A. The other goes, I remove user B. Both need the same dictionary, and your dictionary will say, stop, I can't handle this. So in this case, use concurrent dictionary to safely add and remove users as they come and go. It's the thread-safe dictionary designed to be safely and efficiently used by multiple threads at the same time. And that is everything you need to understand about dictionary in C#. Did I miss any cool dictionary tricks? Let me know in the comments below. Thanks for watching.